Highways play an important role in making travel easier and more expedient. This is of great assistance whether traveling for work or play as well as travel involving transporting goods. Now, I will discuss the geometric design, pavement design, and traffic engineering. Geometric design is a highway that deals with the dimension and layout of visible features of the highway such as alignment, sight distance, and intersection. Also, it should be designed to provide optimal efficiency and traffic operation. Goals of geometric designs are maximize the comfort, safety, and economy of facilities, provide efficiency in traffic operation, provide maximum safety at reasonable cost, and minimize the environmental impacts. There are five important elements of geometric design: cross-section element, site distance, horizontal alignment, vertical alignment, and intersection. The cross-section element includes the traveled way, roadway, median, shoulder, curb, traffic barriers, and drainage channels and side slopes. Traveled way, it is a portion of the roadway provides for the movement of vehicle exclusive of shoulders. Also, it's a number of lane on a traveled way is decided on the basis of expected traffic volumes and the appropriate level or service required for the facility. Roadway, it is the portion of highway provided for vehicular use. It includes both carriageway and shoulder, a way or path over which cyclists, vehicle, and pedestrian can pass lawfully. Next, shoulder. Shoulder are the trips are provided on both sides of the carriageway. There are some functions of shoulders: accommodation of stopped vehicle, emergency use, lateral support for the pavement, space for road safety facilities, space for vehicles and pedestrian driving comfort, improvement in sight distance, and improvement in capacity. Media. It is separate opposing traffic, recovery area for out of control vehicles, stopping area, storage of right turning and U-turning vehicle, minimize headlight glare, provision for future lanes. Curve, it's a dividing line between carriageway and footpath. The function of curves are drainage control, roadway edge delineation, right of way reduction, delineation of pedestrian walkways, reduction and maintenance operation, and assistance in roadside development. Traffic barriers. It is a longitudinal barriers including bridge rail or an impact attenuator used to redirect vehicles from hazards located within an established design clear zone also to prevent median crossover and errant vehicles from going over the side of a grade structure to protect workers occasionally. The last one is drainage channel and side slope. Drainage channels and side slope are provided along the length of the road for stormwater drainage. Channels should have adequate capacity for a design runoff, minimize damage to the highway caused by unusual stormwater, minimize risk for motorists, be resistant to the high-speed water flows, and prevent sedimentation of the particles carried by water. Next, the important element of geometric design is sight distance. It is the length of roadway visible to a driver. The three layers type of sight distance common in roadway designs are intersection sight distance, stopping sight distance, and passing sight distance. Intersection sight distance, it is a driver of a vehicle approaching or departing from intersection should have an unobstructed view of the intersection, including any traffic control devices, and sufficient length along the intersection highway to permit the driver to anticipate and avoid potential collision. Stopping sight distance allows the driver to perceive, react, and safely stop. A minimum stopping sight distance must be available. Stopping sight distance is defined as the sum of two distances: reaction distance and braking distance. Reaction distance, it is based on the reaction time of the driver and the speed of the vehicle. The distance traveled by the vehicle from the instant the driver sees an object necessitating a stop to the instant the brakes are applied. Braking distance. It is dependent upon the vehicle speed and the coefficient of friction between the tires and roadway. The distance traveled by the vehicle from the instant brake application begins the instant when the vehicle has come to a complete stop. Passing sight distance. It is needed where passing is permitted on two-lane, two-way highway to ensure that the passing drivers who use the lane normally reserved for obstructing traffic have a sufficiently clear view ahead to minimize the possibility of collision with an opposing vehicle. Horizontal alignment is one of the most important features of highway design. It is a proper design can result in high performance regarding speed, safety, efficiency, and comfort. In addition, it may result in saving the economy and increasing highway capacity. The design of horizontal alignment requires the understanding of design, speed, and horizontal curve. Horizontal alignment of a road comprises a series of straight lines known as tangent with the provision of chord to change direction. It also includes the design of elevation, extra widening, setback distance, and transition curve design. Vertical alignment. Vertical alignment of highways is generally defined as the presence of height and the depth in the vertical axis with respect to the horizontal axis of alignment. This height and depth in the road may be in the form of gradients, straight line in a vertical plane, or vertical curves. The last one is intersection. Intersection is an area shared by two or more roads. Their area is designated for the vehicles to turn to different directions to reach their desired destination. Its main function is to guide vehicles to their respective direction. Traffic intersections are complex locations in any highway. This is because vehicles moving in different directions want to occupy the same space at the same time. In addition, the pedestrian also seeks same space for crossing. Here we go. We're going to pavement design. Pavement design, it is a structure which separates the types of vehicles from the underlying foundation material. The latter is generally the soil, but it may be structural concrete or a steel bridge there. The objective of pavement design is to determine the total thickness of the pavement. The thickness of each layer of the pavement is found out by designing it with proper inputs, and then the total thickness is found out. There are two types of pavement: flexible pavement and rigid pavement. Flexible pavement are constructed from bituminous or unbound material, and the stress is transmitted to the subgrade through the lateral distribution of the applied load with depth. There are three layers of flexible pavement: surface course, base course, and subbase course. Surface course, it is the layer in contact with traffic loads, and it is provide characteristics such as friction, smoothness, noise control, and drought resistance drainage. Base course. The layer immediately beneath the surface course. It provides additional load distribution and contribution to drainage. The last one is subbase course. It is the layer between the base course and subgrade. It functions primarily as structural support, but it can also minimize the intrusion of lines from the subgrade in the pavement structure and improve drainage. Rigid pavement. It is transmitted to the subgrade through beam slab effect, and the rigid pavement contains sufficient beam strength to be able to break over localized subgrade failures and areas of inadequate support. The largest advantage of using rigid pavement is its durability and ability to hold a shape against traffic and difficult environmental conditions. Although concrete pavement is less expensive but has less maintenance and good design life. Traffic engineering. Traffic engineering is the phase of engineering that deals with the planning, geometric design, traffic operation of road, street, highway and their networks, terminal, commuting lands, and relationship with other modes of transportation for the achievement of safe, efficient, and convenient movement of people. Traffic engineering applies engineering principles that help solve transportation problems by considering the psychology and habit of the transportation system users. Con- Common objective of traffic engineering included the following: providing high-efficient traffic flow through ample research and innovative design efforts, to produce free flow of traffic, use research design to roadways and highways that increase traffic safety. There are three principles in traffic engineering: valorization principle, concentration principle, and legibility principle. Valorization principle means to use only the needed and useful signs. Too many road signs lessen its efficiency. Regulatory and warning signs should be installed sparingly because excessiveness use these signs will only decrease their authority. Concentration principle. It is necessary that some road signs must be seen at the same time. They should be installed for the driver to see at a glance by night and day. The sign must be set on the same post when the two indications relating to the same point are complementary. Legibility principle. It is indication or analogical message should be reduced, and if necessary, road signs should be properly distributed. Experience proved that the average observer cannot see and understand at a glance more than two symbols at a time.